Hello parents, I'm Mrs. DeBaun, a 4th grade teacher at Maple Grove, and today I'm going to show you how to do our long division. I'm going to start with just the basic standard algorithm that you and I learned when we were in elementary school as a base point. So if we do the problem 637 divided by 4, you and I would have learned to take 4 into 6 one time, 1 times 4 is 4, and so on. And we would end up with an answer that looks like this, okay? And unfortunately, we are moving in a new direction for division, and so when you go to help your child, they are not going to be familiar with this. So I want to show you what our kids are actually doing so you'll be able to help them at home as well. So I'm going to do the exact same problem, and we're calling this method the partial quotients method. And so what our kids are going to do to start with is they're going to look for compatible numbers. They're going to start with the 6 and try to think of something they know as a base fact. So the closest base fact that's under 6, of course, would be a 4. So we're going to teach the kids to look at 637 as 400, and that 4 can go into 400 100 times. And then they're going to follow those same steps and do 4 times 100 is 400. Subtract, and we're going to have 237 left over, and then we're going to just do the same thing. This time I'm going to look at the 2, and hopefully the kids will recognize that I'm not thinking 2 goes into 4, it's 4 goes into 2. Well, it can't, so we're going to look at 23. So we're going to say, okay kids, what's the closest base fact to 23 divided by 4? Hopefully they know that that's 20 divided by 4, which would be 5, or in this case 50. So we're going to put a 50 up here, and 50 times 4 is going to be 200. Okay, and we get 37. We're going to start over again. Okay, base fact, 37 divided by 4. Hopefully the kids will recognize, oh, 36 divided by 4 equals 9, and 9 times 4 is 36 with a remainder of 1. And so then we just add our partial quotients up and get 159 remainder 1, just like we did over here. The reason this works for a lot of kids is because it lends itself for a little wiggle room. We might not have kids that know their base facts as well, and so they could do the problem, I'm gonna come over here, exact same way. And let's say they recognize that 100 is a good number, and we're gonna do 400, and we're going to get 237, okay? And they look at 23 and they're like, gosh, I don't know my base facts, so, well, what can I do? Okay, 20 divided by 4, well, maybe they don't recognize that that's 50. So a lot of times what I will tell my kids is, we know our 10s. Pick a 10. 10 times 4 is going to be 40. Now, you might be thinking, holy cow, they're going to go through this problem and it's going to be taking a really long time to go this route. And you're right, it is going to take a really long time to go this route. But they can still get to the same answer. So until they get more familiar with those base facts, this might be the route they have to go. They're going to look at this and go, well, oh, I know that 16 divided by 4 is 4, so this is going to be 40, and then I've got 37, and then 36 divided by 4, we're going to get that 9, and as you can see, they're still going to get 159 remainder 1. So there's a little more wiggle room for our kiddos that aren't really fluent with their base facts yet. So once again, this method is called the partial quotients, and this is the method we will be teaching our kids in 4th grade. Some kids might see the standard algorithm if they can prove mastery in the partial quotients, but that's what we will be sticking with. So if your kids come home and they're showing you this, I want you to be able to be familiar with that so that they're not learning 2 separate ways. And that concludes our mini lesson on partial quotients.